Hello, Maurits here again with some further examples of integrals. So in this case, we should look at f of x equals to 4 minus x squared, and we should find the area enclosed by f of x and the x-axis. Okay, first thing I would say that in almost all cases try to sketch the situation. Independently if you have access to calculator, so sketching will probably help us. So what we have here is that, say, if x is 0, then we get 1, 2, 3, 4, right? If x is 1, we get 4 minus 1 squared, which is 3. And if x is 2, we get 4 minus 2 squared, so we're down to 0. And the same thing on the negative side, so we get graph that looks something like this, right? Should be a little bit more symmetric. Okay, so that's the shape of the curve. And when this in the question, if they say that area enclosed, we talk about a finite area that are in between. So in other words, we're looking for this area. We already know that we should go from a minus 2 to 2, but suppose we didn't know that. Simply what we do is take our function and put that equal to 0. So 0 equals to 4 minus x squared. Okay, we add x squared on both sides. So x squared equals to 4. And then you take the square to both sides. So we get x equals to plus minus square root of 4, which is plus minus 2, exactly as we expected. Okay, so now to find the area, we should integrate from minus 2 to 2 of 4 minus x squared with respect to x. Observe the brackets I have here and here, because that is the whole thing that we should integrate. Next, we need to find the antiderivative of our function. And 4 to start with give us 4x. We can think about this in two ways. We can think that, okay, 4 is the same thing as 4 times x to the power of 0. And using the rule we had about that the antiderivative is x to the power of n plus 1 over n plus 1. That will give us 4x to the power of 1 over 1, which is 4x. Another way to see that is that we know that the derivative of 4x plus some constant equals to 4. So the antiderivative, in other words, is 4x plus some constant. But we don't care about the constant here, since that will cancel away anyhow. So 4x minus, and the antiderivative of x squared is x3 over 3, right? From minus 2 to 2. And this will give us 4 times 2 minus 2 to the power 3 over 3 minus bracket. I suggest you always try to do this step by step instead of doing many steps at once. So 4 times minus 2 minus 2 to the power 3 over 3. Okay, we continue here. 4 times 2 is of course 8, minus 8 thirds, minus bracket, minus 8, and minus 2 to the power 3 is minus 8, and minus of that will be 8, so this will be plus 8 thirds, or 8 minus 8 thirds minus minus, that is plus 8, minus plus, that is minus 8 thirds, or 16 minus 16 thirds. Let's write that all as thirds. So we have 16 times 3 over 3 minus 16 over 3. And I often say this to my students: be smart and lazy. Lazy you are by nature, smart you have to add to the mix. Of course, we could have calculated 16 times 3, but here we immediately see that we take 16 times 3 minus 16, which is 16 times 2. So this will give us 16 times 2 is 32 thirds. Or if we so wish, we could write this as 10 plus 2 thirds. Sometimes you might see this written as 10 and 2 thirds, but I really say don't write like that, because it's hard to see the difference between if you mean multiplication or addition. So write it 10 plus 2 thirds if you want to write it out in mixed form. So let's try this on the calculator. Option, calc, integrate, and what function did we have? We had this, right? 4 minus x squared from -2 to 2, end bracket, enter, and we get 10 and 2 thirds. Yay! I will though not do this integral like this. I will simplify it a bit for me by looking at this again and see that, okay, this is symmetric. This area on this side is equal in size to this area. So I could actually find the area by taking 2 times the integral from 0 to 2. And as we will see, that will be slightly easier. So yet again, we had 4 minus x squared dx equals to 2 times 4x minus x cubed over 3 from 0 to 2 equals to 2 times 4 times 2 minus 2 to the power of 3 over 3, or 2 times 8 minus 8 thirds. We can write that all as thirds, so that will be 2 times, and of course I missed to say this, if I plug the 0 into this, that would be 0, so technically speaking we have a minus 0 here that we don't need to care about. That's the idea behind using the symmetry thing, that we don't need to calculate anything particular for one of the two ends of our interval. And of course 8 times 3 over 3 minus 8 thirds, that will become 2 times 8 times 2, since we have 8 times 3 minus 8, which is 16 thirds, which will turn to the same thing we had before, 32 thirds, so that is slightly simpler. So here we have an example of finding an area with some kind of question about that is enclosed by some conditions. Let's look at another example of an integral. Say we are asked to find the integral from 1 to 3 of 1 over x dx. That's, by the way, mostly written as the integral from 1 to 3 of dx over x, means the same thing. And if we try to use the rule that we had here, that the integral of x to the power of n dx equals to x to the power of n plus 1 over n plus 1 plus c, we will fail, because 1 over x is x to the power of minus 1, and if we try to do that, we get minus, here we will get minus 1 plus 1, and that would be the 0. We can't divide by 0. But we had one rule previously on derivatives that says that the derivative of ln x is 1 over x. In other words, the antiderivative of 1 over x is ln x, and that is what we will use here. So this will give us ln of x from 1 to 3, and that will give us ln of 3 minus ln of 1. And we have to think here, ln of 1 means answering the question, what do you need to take e to the power of to get 1? Oh, that's 0. So this is 0. So in other words, we just have the answer ln of 3. And in general, if we look at the 1 over x curve from 1 to some value b, we can see that this area here is ln of b, which is rather interesting. We have a physical kind of representation of what logarithms stand for. It would be this area under 1 over x, which is pretty cool too. Anyhow, hope this helps a bit. Bye.